Hello and welcome to the first Func Prog Sweden this year from Sweden. We had already had the first Func Prog Sweden, but then 1 week ago, live from Vietnam. First up, I would like to thank all our recurring viewers of Func Prog Sweden Meetup. Welcome back. And then to our new viewers of Func Prog Sweden, this is the meetup where we explore functional programming like Erlang, Elixir, Haskell, F#, Dart, Scala and more. Not to forget to mention Clojure also. And we have also explored different functional programming styles in other programming languages like C++ and Java and more. So warm welcome to Func Prog Sweden Meetup. Let's head over to the agenda. First up, intro by me, Magnus Sedlacek. Then we'll head over to the presentation of the day, Elixir and its lab by Cédric. First up, I would like to thank our video sponsor, Adabit. Adabit is a IT consultancy company based in Stockholm, with offices both in Stockholm and in Vietnam. Hence, we were in Vietnam last week. So thank you very much, Adabit, for the sponsoring of the video stream. And then the coming schedule for the spring. First, next meetup will be at Kivra in Stockholm. Then 21st of March, we're back here in the studio from Stockholm, and then we'll run another one in April and then in May, yet to be decided where. If you want to support the Func Prog Sweden community, head over to Meetup and join the Meetup group, and make sure to follow us and subscribe to our channel. And if you really like Func Prog Sweden and want to sponsor the community, you can get a t-shirt like I have here, with a nice print. If you don't like t-shirts, there are coffee mugs and more. And as always, if you have questions during the live stream, shout out in the YouTube chat, and I will read it up to the presenter. With that said, let's get started. First and only presentation, Elixir and its lab by Cédric. Welcome, Cédric, to Func Prog Sweden.
For having me.
Yeah, we hear you. Welcome, Cédric, to Func Prog Sweden.
So, I think we can begin directly because I already have a slide for thanks, because I think it's important to give thanks to people. First of all, to Func Prog Sweden for having me, and then to restreamu.se to handle everything, every logistic part, because it may seem simple, but it's quite hard. And then to you, Magnus, for hosting this presentation.
You're welcome. The stage is yours.
Yeah, thank you. So yeah, Elixir and its lab. So once again, thanks Magnus, and especially him because he contacted me on LinkedIn in September to just present me about this meetup group and this YouTube channel, which is really interesting, by the way. And I just replied to him like if he looked for anyone to give a talk, then I could be one of them. And he actually looked for someone in January, so today. Then the other question was what to talk about. I already gave some talk about different topics. One was about refactoring, was one about testing new languages. But Magnus came with this idea of presenting Elixir, which I think is like really good for multiple reasons. One of them is because it's a hard exercise, especially to talk about something you've been using for multiple years, 5 in my case. It's easy to forget what make it like the grain and the first things you see as you explore it. But also it's a great talk because it forces you to analyze what you do. But the thing is, it can be like replied in this question can be replied in a really short way. Elixir is a functional untyped compiled concurrent, so it uses process for concurrency. language, so functional and type compiled language. It's based on Erlang, the Beam, and OTP. It's fault tolerant, and the main thing you should use it's pipe, pattern matching, and words to organize your code. We could also say it's based on Ruby for the syntax and other few things, but the reality is like you may already have watched videos such as 100 seconds of Elixir, or even other elements such as the elixir-long.org, which is the one which has a learning page with books or in-depth book, courses, screencasts, and other resources. Or even find an article written by some people, maybe one like mine. So it wasn't really interesting to just give a talk about only Elixir. And while I was thinking about this subject, I came across this big tree, which is a tree for science fiction and all the movement inside science fiction, which this tree is written in French and it's not available anymore on Wikipedia. But I think it's really interesting because it also shows the evolution and progress of science fiction in time. And if you compare to other methods of presenting topics and the evolution of the language and the associated elements, one can be the iceberg or list. But the complexity in the inheritance is best shown with a tree. And that's why I think the idea of tree was really great. And I tried to do mine, which is, I'm not a graphist at all, but it looks kind of like that. You can see at the roots, there is Erlang, OTP, and Beam, and then growing on top of that, there is Elixir with the different tools, Mix and IOX, which are the main tool you will use to start a project, or the command line. You have Phoenix, LiveView, which are the web part, which is the most used, and then you have other tools such as documentation, format, spec, or ExUnit, and a lot of other tools, which I will present in this talk, which I think are really interesting. We will not go in depth for most of the tools. We'll also have some kind of live coding, even if it's just a hello world with a little bit of format, a little bit of spec and documentation. But the idea is to show you what Elixir proposes and to give you the opportunity to ask questions on subjects you may be interested in, and for me to try to answer. I won't lie, as I said, it's been only 5 years that I've been programming almost daily with this language, and there is a lot of things to do, notably NIFs, I never touch them. Distillery, I barely touch them. Distillery is a release tool, so I won't be able to answer like really specific questions on some topics. But the idea is today for me to help you see if Elixir can be interesting for you, either because you are willing to learn a new language, or because you may also consider a new language for a new project in your company or whatever reason. So this will be me giving you a case for Elixir. But first, let's begin with a bit of history. I think history is great for many reasons, and especially to understand the context in which a language was created. And in this case, the context was the telephony and connectivity. And telephony came back exists since the 19th century. At the end, it was mainly operated by humans behind big boards. They got a call in and they had to link the call to another end, and it was done manually. Then, I think it was in the 30s, began to appear like automated machineries, but it was still like automated and physical. And it evolved in the 80s or 90s to something you can see on the right of the screen right now, which is way more optimal, but still those are switches, telephony switches. And by the way, a switch works with those all phone, and it's another switch, which is a little bit more like simpler. The idea is like it uses 10 abilities and it's able to count. And so if you put your finger in one and then you turn, then it will only be one click. And the machinery will detect one click and begin to organize the phone transmission. And then with the other one, the next number, it will check another one. And it will create the connection through this set of number, but it will be done mechanically. And the problem is mechanic can, well, fail at some, well, everything can fail, but mechanic can be used, can get used at some point, and you need to replace them. And you need to replace them to interrupt the service. And it takes a lot of place because the mechanic is not scalable, or at least not scalable in nanometers or even micrometers. So that's why Erlang, which is the base for Elixir, was invented. It is fault tolerant. So if there is a problem, Erlang will just keep running. It will just forget about this problem. Maybe it will be logged, but it will not stop the server at all. It is also designed to have a strong availability because maybe at some point, maybe for New Year, for example, people want to call each other, to greet each other and wish Happy New Year, for example. So it needs to be like have the capacity to handle a lot and at any time. So a strong availability. It also needs to be real time, distributed, and to avoid this problem of having to change a piece. The code should be should be able to do hard code upgrades, which mean your code is running in production and you don't stop it. You just it keeps running and you push new code inside of it. And once it's done doing its task, it will add the upgrade in the list of things to do, and it will do it when it's time to do it. So it doesn't stop. And that was the need behind Erlang, and that's why Erlang was created. So I spoke about Erlang, but today we can speak about Erlang without talking about Open Telecom Platform and the Beam. And I'm not an Erlang developer, so I will just say a few words about Erlang. It was developed in 1987 by Ericsson. Actually, it wasn't open source until 1998, if I recall correctly. Today's version, it's 25.3, which is quite high for a language. It's unlike Elixir, it's immutable. Otherwise, it's really similar to Elixir. And the base for the syntax is Prog. Then OTP. OTP is a set of Erlang libraries and design principle. Inside all those libraries, there is one database, which is Amnesia, which can be used either as a cache databases or which can be used also as a classical databases. So it will be more linked to NoSQL than SQL. You have also interoperability, which is linked to the NIFs. As I said, we'll talk about this later, but the idea is just give you a framework to be able to use other languages and other functions from other languages. Then you have debugging tools and release handling tools, which I will talk also a bit later. Finally, the Beam, or today we don't know if it's for Bogdan or Bjorn Erlang abstract machine. Bogdan was the creator of the Beam. Bjorn is the maintainer, is the one who works on it and help it keep updated and stuff like that. So the Erlang abstract machine is a virtual machine. It's kind of similar to the Java machine, so JVE, if I recall correctly. It is part of the Erlang runtime system. So the ERTS, I won't speak about this today. I will just say that the other part of the ERTS is the compilation, and maybe there is also another one, but it's mostly the compilation and then the abstract machine, which run the Beam bytecode, as said in the next point. So the abstract machine doesn't understand Erlang or Elixir. It understands what's compiled from Erlang or Elixir to bytecode, and that's how it works. It also has a strong process management. The idea is for this machine to be able to spawn multiple processes at once in not even microseconds, but nanoseconds. Oh, no, sorry, not even in milliseconds, it's in microseconds. And that's why sometimes when we run Elixir code, we don't have millisecond, for example, if we want to test a connection toward another machine, but we can have elements in microseconds, which is like kind of satisfying, if I can say. So back to the main topic, Elixir. Elixir was invented by this man, well, José Valim. The purpose behind this invention was higher productivity or extensibility of the BM. It's also easier to approach in the way that Elixir is based on the Ruby syntax, and today, and even since the beginning of the 2000s, the years 2000, the vast majority of people program with object-oriented languages, and switching from object-oriented to, I will say, old school syntax or Lisp syntax, Prog syntax, programming functional language is quite hard for most people. So Elixir is like really easy for them because it's similar to Ruby or to even PHP in some cases, or other object-oriented languages, and it's like really easier to approach, and that's also one of the reasons, I think. Then the last one of the main reason was large-scale sites and apps. So it's designed not only to handle like Erlang is able to, but it's also designed so it's easy to program and to manage a team around the code base to maintain and scale and upgrade and update large-scale sites and applications. So, as I said, this will be a talk about tools and a little bit of live threading, and I think that's exactly what I will do right now. So, to start a project in Elixir, it's quite simple. You use Mix. So Mix is the tool to access most of the library of most of the commands. And right now, we can just create Mix new and define in this file an app which will be called demo. Yeah. So yeah, that's true. So once the project is created, you can just access demo Func and start coding. If we want, we can also just create a file which is example.ix, and if we go to example.ix, well, obviously it will be empty. We can just then begin to program, and everything in Elixir, like you are not obliged to create a module to write something in Elixir, and this will be the example. The famous hello world. Just save. To run something in Elixir, you just write Elixir and then example, and it will print hello world. But as I want to show you the syntax, it will actually be more interesting to show you what we commonly use, which are modules. So it can be just test, and then we define a do, and at the end of the module, it's end with an end, and then the function, which can be hello, and can take an argument, which will be a string. So here I will use actually what we call a guard to just validate that the string is actually a string. and then we can just do string, and we'll call it directly from outside. Well, no, let's use AUX. Actually, I will introduce you to AUX as well, which should work. AUX is actually the like you can see the like code interpreter, like where you can execute live Elixir code. So if I just put once again hello world through AUPuts, it will tell me, it will print hello world and then send me back okay, because like most languages, every function returns something. So I imported test, so I should be able to do test.hello with string inside, and we can see it print world. Now with the code, if I put an integer, it will just fail. It will send me an error. So I can directly from IEX modify it. It will not save it in the file, but I will be able to modify it if I want. So I can just def module test right now and do the same thing. Test hello string, one is binary string. And now we'll add the safeguard, so a function which will accept any kind of argument. And it will just help us do our basic save and avoid any error if call it. Oh, sorry, live coding. Yeah, let's just this. And here we go. So now we can just do test hello. Once again, we write world to validate it works. And if I put 1, it will print 1 and send 1 back, because once we use puts, which is only used for string, but then we use inspect. So with only that, you have already a view of the basic syntax, which once again is based on modules like Ruby and the def variable. We have variable name, which are quite simple. We have guards. I didn't show yet how to do pattern matching or pipes, but I don't know if I have time, so maybe I will show you at the end. But yeah, the idea is the syntax is more similar to Ruby and then than to Prog, which Erlang is based on, or even to Erlang, and it's quite easy to take in hand once you, well, if you come from the object-oriented world. Also, I just show you mix, which actually, if I go back to the project, which is demystified, yeah, I could add different tools. One of them is whatever it is. It's a tool to reformat, so it's format.exs. So exs, unlike ex, is for script, Elixir script, and format.exs just allows us to have a linter, but it's directly integrated with Elixir, which helps us have a community thing. So those are some of the tools. I haven't showed Exdoc. Exdoc is one of the best documentation tools we can have, actually, like quite easily. The website is just as that. And if I go to kernel, for example, the kernel, you'll see navigating on the Elixir documentation is really easy, because like it's quite clear. You have different module. If I go to enum, for example, I also have access to the function directly on the side. And if I go, for example, to each, then you have the explanation of this function and an example. The good thing is you can directly add documentation code to generate this documentation directly on the Exdocs once you registered your library to the Exdoc list, and it will just use your mark in your code to define this. So if I do a quick add, okay, sorry, that's there. So to add just documentation, we generally do at doc, and then as simple as that, and it will be your documentation. And that's enough for it to understand how to generate documentation. So IEX, the syntax, you've seen the syntax, you've seen the documentation, you've seen mix, we've talked about the format. We haven't spoke about specs, but I won't go far, just like the documentation, but instead of being a documentation, it just gives the argument, like the type function, the function arguments are. So for example, if my function is just an addition, it takes 2 numbers, and the spec will be function name, integer, and that will be it. And what it returns is another integer. More details later if we have enough time. So that's about it. I haven't shown you ExUnit and ExCoverall because those tools are the basics. They are part of the ecosystem directly integrated inside Elixir. So like you don't have to look for new library or something like that. And it's really great because those are for testings. And ExUnit is a base for testing. You just define your file, which contains tests, and it will use mix. You will just do mix space test, and it will run the test in your files. And then you can also use ExCoverall, which is an external library which analyzes everything the test does and every line of code that's used to report if you have an uncovered line somewhere in your code of how well your code coverage is. Those are the two tools. Coverall is done by the community, as I said. Elixir is easy to learn. This is, like, as I said, it's a functional approach, which is easy to learn because Elixir is also like really strong for the concurrency. And we will talk about this later. Remember the tree every time. We are going from bottom to top, and the Elixir part, the central part, is the easiest one. And it's easy to learn. The reason I say that is because I did the code on the right in 3 hours after learning it. And without explaining everything it does, just take GraphQL and mimic GraphQL when you pass argument and fields. And it can take like a lot. It can handle everything. At the time, I was mostly a PHP developer. I tried to do it in PHP, and it took actually, like I think it was 120 lines of code instead of a little bit less than 50 because we have 6 lines of code about testing and other things. So it was really great to see the difference and to experiment. I guess in a way, you can do that as short as that or even shorter in other functional languages. But if you come like me from the object-oriented programming languages, then it's really strong, and especially doing so in 3 hours. You have words, you have pattern matching, you have pipes, which I haven't talked in depth, but which are, like, as I said, the base of Elixir programming, at least when I teach to some people, whether they are co-workers or people who wanted to learn. And it really helped to have this vision. So it's really easy. Another thing is like you can easily find articles on the internet saying that people learned Elixir and in 2 days they were able to be functional with it. And in less than 1 week, they were able to deploy things on the production environment. So in less than a week, which is like really great, really, really powerful. So the functional part and the functional approach is really easy to learn or to get access at least. But it's not only the tool I've shown you, which are, I think, similar to most languages, documentation, testing, like the mix tool, which is the library manager and function manager, also the code interface, live code interface. Those tools are common to most languages, but Elixir has some also integrated tools which are like really interesting, I think. And I also wanted to talk about them to give you the big picture. And well, the two first I will talk about are plugs and Phoenix. Actually, I will also be able to start to create a Phoenix application. To do so, we simply new umbrella, and I will come to the umbrella later on. So let's say there is an error because I need, yeah, Phoenix example. And while it's created, or while it downloads the dependencies, Phoenix is actually based on Plug. It's the web framework for Elixir. It's at least one of them, and definitely the most used. It's the tool, like I think the first tool I really used from Elixir. And today I'm also doing mostly web programming, which is based on Phoenix. But Phoenix is based, as I said, on Plug. And Plug, to get back to it, is a library directly included, not included with Elixir, but it's developed at the same time as Elixir. So if you have Elixir 14, you will probably have Plug 1.14, other things like that. And the idea behind Plug is to give you the possibility to actually define a module which will do a specific thing. So it can be Plug dot authenticate, for example, and actually it already exists, and you can just add the plug authenticate as the first, and then add another plug, then plug, and then add another plug, and you can just create a workflow of HTTP connection and HTTP verification with plugs, and it helps you simply create your own web framework if you don't need everything Phoenix brings. So it's just a base for HTTP connection, HTTP request, and a little bit more. That's what Plug does. And Phoenix, to go to this, adds way more. So let's explore a little bit Phoenix, actually. We can see this is an umbrella, so I won't go directly to the umbrella right now. We'll just go to the Phoenix example web, which is a part with the assets. As you can see, the assets are CSS, JavaScript. It's kind of basic, and then you can go to the lib, and inside the lib you can see there is telemetry, which I will talk about later. There is a router. So if I show you the router, you'll see there is already like some routes which are enabled. You have plugs, as I said, which are from a pipeline, and so this is one of the things. There is a router, but you also have views. If I go to views, you'll see there is like helpers and the layout and other things. So Phoenix will generate a lot of things for you, and if you want to have a web framework which is like really performant and gives you a lot of things out of the page instead of having to create your own plugs and design your own web framework with Plug, then you will probably go with Phoenix, as most people do. So it gets hot because on top of Phoenix, and it's quite recent, we have LiveView and LiveBook. LiveView, to make it simple, is an abstraction of JavaScript, which allows you to basically have like hot reloads on your pages without having to code any JavaScript at all. The idea is like we are Elixir developers, and we should be able to just send a minimum amount of data and to update just a specific part of the page without having to reload everything or send the biggest amount of data or whatever it is. And then we have LiveBook, and actually LiveBook uses LiveView, so I will be able to show you LiveView with LiveBook. For those of you who already know LiveBook, oh well, for those of you who know JupyterBook from Python, well, LiveBook is actually something which is like really similar, but which also can be connected to a lot of things. So let me just start my server, and we'll explore a little bit of LiveBook, and we'll see how LiveView works. So I just have to copy the URL right here. And so this is LiveBook. I can just simply create an ebook and to explore that. And what will be really interesting is at the same time exploring the network, because this is where things are done. And if we look at at WebSockets, then we have two established WebSockets, and that's how LiveView works. You don't use like classical HTTP REST connection. The idea behind LiveView is for you to update specific part of the page, and to get data, it will just create a link with WebSockets and keep the link alive, and it will send you data from the WebSocket. So right now, if I just put my famous hello world once again, I can run it directly. If I, just here, it will once again display that. But then if I if I open my WebSocket, which should be able, we can see like two requests row transferred. I should be able to see some connections and request and response. Yeah, you can see. And if I reload the page, it will be saved. It won't be saved through classical interaction, because if once again I create a new block, for example, let's add a markdown just between them. Let's chicken, so it takes 3, and like forget about that. My markdown is done. I can just edit it if I want. It will open the window. There is no post method, but then if I reload once again, it will be there. You can see the example is here. So that's what LiveView and an example of LiveView does on LiveBook, and you can see how LiveBook can be like used. This is just a fraction of its power, because you can import library, and you can even connect to some elements through the node name and other stuff like that. And I have access directly to the live code inside the node you are connected to. So it's a really great tool, especially if you have to remove or like to inspect a code which have been making errors for some reason, and you don't have access to the data on your local machine or other things like that. But yeah, let's continue. We could everything, every element, even if it's like Phoenix, LiveBook, ExUnit, every one of these elements could be the subject of a 1-hour talk at least. So it's really condensed. I'm sorry if like you have trouble following, or if it's not clear enough. But that's why I hope you will ask questions at the end. Yeah, so let's continue. Now it's the part of concurrency, and as I said, the Beam server create concurrency through the idea of processes. So it's an Ecto model. For those of you who knows what an Ecto model is, otherwise you will have to search on the internet. I'm sorry for that. Maybe just ask the new AI about that. The idea behind the GenServer is that you should be able to spawn a process and to define it. So either if it's short-lived or long-lived, if it's a supervisor or if it's an actor, if it's a task or whatever it is, maybe you want to store data for a certain time. So we'll use a GenServer to store them. Or maybe you want to just execute a code and be done with it. So the GenServer will also handle it. This is the idea of the concurrency behind Elixir. It will just, when you create a GenServer, it will just basically create a process inside the Beam machine, and it will execute the code which is associated to it. I could actually show you, if I have time at the end, once again, there is like a tool which allows us to see every processes that are running on our Beam machine. Then we have Ecto. So Ecto, I put it with the GenServer and concurrency because it's the first tool people use, which actually use dynamically GenServers and concurrency. Ecto is our tool to connect and to interact with the databases. I think it's called an ORM. Basically, it's just that. It's like any other ORM. The only difference is that you have to spawn a few processes at the start of your server, which will stay connected to your database. And that's why it's linked to GenServer. You have to put it in a specific place, which is the application file, which actually starts all the children which have to be started. Then there's Nerves. Nerves is an application, well, a framework to do to connect a lot of physical tools. So it's great for automating your house. For example, if you have an oven or like shutters that are connected. So, well, you can use Nerve to create a server which will handle everything in your home and make it easier to manage everything. So that's the use of Nerves. I've never used it, so I won't be able to talk about it, but it exists. It's a great framework, like really advised for most people, by most people which used it, or from what I heard. And it gives you other options than just doing web with Elixirs. Also, finally, RabbitMQ. Well, I put it here because it's, even if it's not written in Elixir, it's written in Erlang, and I've actually tried to reproduce it with Elixir, which is a really great exercise because you have to handle a lot of different GenServers. And if you ever go and do a project in Erlang, or if you ever learn Erlang or Elixir, actually, both languages, whatever, you can try to create or to recreate RabbitMQ as a really good exercise. It will take a few weeks, but then you will be able to understand how queues work, how load balancing works, and because you will have experimented it and not just read about it, or at least in the Elixir environment and Erlang environment. I think there is still a few last tools. Well, those are not tools. There is MetaProgramming and native implemented functions. MetaProgramming is like different level, but I can actually do something really quick, which is quad do, if I recall correctly. Yeah, I think it's that quad do, for example, 1+1. And I actually have the syntax tree of the operation 1+1. And so I have the function plus, which is hosted in the context of Elixir, which itself, well, in the ground context of Elixir, which itself need to import 1 from kernel and 2 from kernel, which are the arguments, and then one and the other one are actually the arguments which are given to the plus function. So that's actually the base of metaprogramming in Elixir. Quote, most people actually use metaprogramming in Elixir because one of the words to import content from other module, which one I used was alias, but one of them is use. Use actually at compile time will just write what's in the module which is used and copy it to the module which use the main import. So metaprogramming can go like really can be like really easy to access in a way, but it can go like really far, and it shouldn't be done easily, at least, especially if you use languages that allow huge options on metaprogramming. Then we have native implemented functions. As I said, Erlang and OTP give you tools to use functions from other languages. So it's something like not common, but if you want to boost, for example, like really high intensive calculus, which functional programming languages may not be done for, then you can just write something in Rust or C and use an if to call this function you just wrote. I've never done it once again, so I won't be able to go deeper than that. But it exists, and once again, it's one element more to consider if you want to try the Elixir, if you hesitate to try Elixir, or if you hesitate to use Elixir for another project. Finally, so I already spoke about ExUnit, that's my bad. Telemetry and release Distillery. Telemetry is a tool to log. It's not really linked to OpenTelemetry, but you can create a link with a library which is associated. The idea is just to normalize logs. So Elixir has logs as most languages do. Telemetry is a standardization of it. It's an external library, and then you have release and Distillery. Release was added, I think it's in 1.8 or 1.9 of Elixir. Today we are at 1.14. But before that, there was Distillery, and Distillery is a library which is way stronger to create releases and give you different options. Either you want to release something in hot code, like production live, and you don't want to interrupt your service, or you want other things, and you can configure it in Distillery, but then it's way harder to control and to manage than release is. And finally, I talked a little bit about Umbrella. It's more like the cherry on the cake. And I'll go once again to my code. Go Phoenix example Umbrella. So if we go in apps, we can see on an Umbrella app, we have two different apps. And this is generated by Mix Phoenix. And we can add actually different new apps. If I do mix new third app, for example, it will just generate a third app, and it will be included in the main application, in the Umbrella application. And it will run with. The idea of an Umbrella application is when you develop, the Umbrella is open, okay? And so you can see the different applications separated. But when you compile, the Umbrella closes and all applications can interact with one another. So it's really great to separate code. For example, the admin website, the admin front end, the classical user front end, your core application, maybe your mail application, whatever it is, and you can have different applications running, but still being separated in the code. So it's like a really useful thing to organize your code. Something which doesn't exist yet, it's the type system. So I've been in the Elixir Paris meetup, which was in November, and in this meetup, well, the 20th, as I'm French, I haven't explained that yet. Maybe you could have guessed with my accent. In this meetup, we had a student, a doctorand, someone who study and as a doctor IT, and especially programming languages. And he works with José Valim, which is, once again, the creator of Elixir. He worked to implement type system, like strong type system in Elixir, because spec is just a documentation in a way. So types are coming at some point. They will be coming in Elixir, hopefully. So we'll be able to have either a strongly dynamic application or well, either a dynamic application or a strongly typed application, which will give us more options to evolve our code base and, well, either maintain or adapt, or like if we decide to go untyped, then make it like easier to, well, faster to program, other stuff like that. So that's what's coming up, and that's, I think, leads to the question where to begin. So as I said, one of the last talk I gave was about discovering languages, and I use the example of Elixir pipes and pattern matching. You can just go read the article. It's 6 minutes, and it gives you a follow-up to try to program a few things in Elixir to test them. I use pipes and pattern matching once again, because it's not something which is really used or really present in object-oriented languages, even though, for example, Ruby tried to implement its own version of pattern matching. And because I write this article for as many developers as I can, it was obviously more oriented for well, object-oriented programmer, because there is way more of them. But it's still a nice article to read. And it's also, the purpose of this article is not to teach you specifically Elixir or pipes and pattern matching. It's to invite you to discover languages and to spend 30 minutes every week or every month, depending on how frequently you want to explore or discover new languages. And just, it's not even to learn, just explore one feature of this language. And so I think it can be a good beginning, but obviously you have other pages and other resources which are accessible through there. Most of them actually are about Elixir. But once again, it's not only about Elixir. Those are actually resources which are available inside the company I work in. It's in our documentation tool, but we want it to be accessible by everyone, because we curate them, and we think it's something which can help everyone. So I think it's your turn now to explore and to ask questions if you have any.
Thank you very much. Thank you, Cédric. Great talk. And also great, you started with the great history of telecom, and then how it kind of shaped into what it is and why it is. Thank you very much. I'm checking the chat. There's no question there yet, but I have some questions for you. When did you start with it, Elixir?
So as I said, a little bit more than 5 years ago. To be more precise, it will be August 2017. But 2017 or 2018? No, 2017, yeah.
Yeah.
So it's been 5 years and almost 6 months now.
Okay. What did you talked a bit that you said you did PHP before. Have you done other computer languages?
So in the school it was postgraduate school. It was 5 years. We started with C, and then we went to C++ in second year, and I did some Python, I did some OCaml. OCaml was quite hard for me because coming from C, it's quite different way of thinking. And then at the time, reaching the third year, I became also independent, so working for other people, but just for client directly, but by myself. And then I learned JavaScript, PHP, and yeah, that's how I evolved to Elixir. Did some Go also.
How come did you stumble upon Elixir, or did you just search for a better tool, or how come you went into or found it, or?
So I worked at a company which is called Mailjet at some point. Mailjet was specialized in sending mails, but then they went for Go. And at the time, I was what we call a developer evangelist, even though it wasn't like really known at the time. And I was tasked with maintaining libraries to help our clients connect to our API. And when I worked with Ruby, because the Ruby library was like really bad, we also asked external people to help us, and one of them talked about Elixir. And then a few months later, almost a year later, I began to start a project. The idea of the project was to create a place where you could connect, identify to different social media such as Facebook, Twitter, and so on. And by doing so, you will have a personal feed from people you liked or followed from every platforms. And instead of having to go to the different places, and actually most people just go to two social media, well, mainly go to two social medias, and you will have all the new news linked to the group you wanted to follow, or the politician or the company, whatever it is. And because it needed to be like high availability, high connection, I had multiple choices, but PHP wasn't one. So I could have gone for Go, I could have gone for JavaScript, but I didn't like the idea that JavaScript was, it's way too wild. I have to say it like that. There is so many libraries, it's giving me a headache.
Yep.
And Go is good, but for microservice and mostly for server side, and I needed also a front. So Elixir seemed like the perfect option for this thing, especially coming from, as I said, PHP. The syntax, the Ruby-like syntax was really helpful. And also reprogramming a kind of GraphQL, or at least the base of GraphQL in less than 3 hours after reading a course of Elixir just sold it to me. So, yeah.
What do you work with today? Are you working with Elixir today in the current projects?
Yeah, I am. We are doing, well, the startup I'm in, we are 6, it's called Goods ID, not ID like an ID, but ID as an identifier. And we are actually creating, how do you say that? We are digitalizing the paper which authenticates a good, like for example a ring, and we put it in the blockchain. But we are starting to work with other kind of clients, such as airplanes or soon hopefully cars or electric bike, to give a maintenance journal and to store events in the blockchain to really give, how do you say, something which can't be modified. And so if it can be modified, either it's wrong and it was modified, but we know it was modified and the data we have are not valid anymore, or if it's because it's a comparison with the blockchain. So you compare the data you have with the hash generated and stored in the blockchain. But if the data are still valid, then the hash will compare the data with the hash generated in the blockchain. If it's valid, then it will prove that the data are actually unchanged. And it's used mostly like that to prove something.
Yep. Another question. Will you share the presentation and the examples you did today?
Oh yeah, no problem.
Yeah, great. I mean, you can put them up on your own link, or just send the link to me, and we will publish them with the video and in the meetup page.
I will do so.
Everyone can share them. Yeah, and any other links you want to share, just flip them over. We'll put them out so people find it.
I think they are on the presentation, but
oh, good, good, perfect. With that, there's no more questions. Again, thank you very much, Cédric. It was very interesting presentation. Myself, I never worked with Elixir. I worked with Erlang and other computer languages, but not with Elixir. So nice presentation, and also like a nice intro to Elixir. Again, thank you very much.
Well, thank you for having me.
Yes, thank you. You're welcome. With that, we are done for today. Thank you very much for joining Func Sweden, and see you next time in either live in Kivra or on the stream. So with that, have a great evening or day or wherever you are. See you next time. Bye.